Hello, I'm Luis Serrano, and this video is about several topics including agents, retrieval augmented generation, reasoning models, preambles, and other techniques that can make your LLM work really well. This is the second of a series of videos, where in the first one, we talked in detail about the strengths and weaknesses of LLMs, but you don't need to see the first one to get this video. In this video, we're going to learn some really good techniques which help us get the best out of an LLMs, like RAG, reasoning models, and AI agents. So I can tell you very quickly what we saw in the previous video of strengths and weaknesses. Basically, we see an LLM like a car that has a headlight to see to the front and a rear view mirror to see to the back. Except that this car is very peculiar. It has a very, very low and dim headlight that can only produce one word at a time. It cannot plan many words ahead. On the other hand, it has a huge rearview mirror that has a zoom, a microscope, a telescope. It can see kilometers to the back in detail. It can do whatever it wants. It can see basically all of human knowledge. And that makes models be really good at understanding, and that's why predictive machine learning is so successful, but it makes them very bad at creating, which is why generative AI, although it's been doing well, it has a lot of challenges. In particular, in the last video, we saw a challenge, which is LLMs cannot tell very good jokes, because for a joke, you need to plan ahead, and with this one word at a time thing, it becomes really hard. On the other hand, things like understanding jokes are very easy because you put the joke in the rearview mirror. So in this video, I'm going to show you 4 really good techniques that will help us get the best out of an LLM. The first one is very simple. It's the preamble, then retrieval augmented generation or RAG, then reasoning models, and finally AI agents. The first one is a very simple technique. It's called the preamble. And it really just says, if you train a model with the internet, you ask it a question, it's going to reply the way the internet talks. So what do you want? Well, if you want this to work as a chatbot for your company or something, you kind of have to make it be nicer. So you can just write a preamble. A preamble is a set of instructions that the model has to read every single time it answers a question. The preamble can say you're a respectful chatbot, make sure you ask follow-up questions, make sure you say bye to the user, blah, 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 whatever you want. And then the model has to read that preamble every time it reads a question. It puts it in the rearview mirror, so then it's going to become much nicer. So that's a very, very easy technique that, as you can see, works quite well, and you should always use it if you are building a chatbot. The next technique is called RAG, Retrieval Augmented Generation, and it's very simple too. So let me give you an example. The day after 2025 US Open in tennis, I asked the model who won the 2025 US Open, and it didn't really know. It thought it hadn't occurred before because, to be fair, if it's just used to what the next word is, it's not going to find out who won the 2025 US Open the day after the US Open. That would take magic. But then I asked it again, and I pressed this blue button that says search, and then it answered correctly. So what happened there? What is behind this button? Well, behind this button, there is RAG, and it's pretty much giving you the instruction. Before you open your mouth, look up the answer on Google or on Wikipedia or in any database that I give you. And if you find the answer, then answer with that answer. And if you don't, then say, I don't know. And that uses the rearview mirror, because if I ask it, for example, what's the capital of Rwanda? Maybe the model knows, but maybe it's going to be like, I don't know, is it Kinshasa? It's not Kinshasa, it's Kigali. So I can give it a preamble. It says, hey, before talking, look up the answer on Google. And if you don't find it, say, I don't know. And if you find it, then put it in the rearview mirror. So it looks it up. It finds Kigali. It puts a lot of information in the rearview mirror. It could take the first 3 or the first 5 or the first 10 results and just put them all in the rearview mirror. It's got the attention mechanism. It's able to look in the right places. And so with all that in the rearview mirror, it's going to be able to say, oh, I'm sorry, the answer was Kigali. So here is how RAG works. Let's say that the question, maybe your uncle calls you or something, asking you a question, and it's not the perfectly worded question. It just says, I'm trying to remember what was the capital of Rwanda. I thought I knew it, but I'm not so sure. So if you're going to search in Google, you don't copy paste this, right? Humans have developed a skill for the last 20 something years, and we know how to search on Google. So we turn that question into a Google search query, which is capital of Rwanda. And then we search it. So this first part is easy for an LLM to turn the question into a search query. What's hard is for it to find the information. So for that, we make it search in Wikipedia, for example. And then with all that information put in the rearview mirror, we make it answer the question. And it says, of course, the capital of Rwanda is Kigali. So this last part used an LLM to put all that stuff in the rearview mirror and answer word by word with all that information. So it's got very, very little opportunity to make a mistake. Another strategy to make the models talk well is reasoning models. So these are more used for solving math problems or programming problems or things that require logic. Let me ask you a question. Let's say you have two students and you make the two students write a math exam. The first student looks at the exam, starts writing the answer frantically. The second student instead starts writing a lot of drafts. And then after a few minutes of writing drafts, they start writing the answer. Just knowing that and no more, which student would you put your money on? Well, I think I would put it more on the second one because you're more likely to be right if you wrote a lot of drafts and were able to mess up and to try different things and maybe the solution is somewhere here. So maybe not, maybe that one's a genius, but it's likely that the one who wrote drafts will do better. This is exactly a reasoning model. A reasoning model basically uses that rearview mirror instead of the headlight. So if you ask it a question, solve for x in the equation x plus 3 equals 10. Well, the model will maybe answer it correctly, maybe answer it wrong. The model is a model that picks the next word in a sentence. That's not math. Picking the next word in a sentence is a completely different skill than math. And so maybe reading the entire internet and learning the structure of the next word, maybe math is included there. Maybe you learn how to add, maybe you learn some things, but complicated math, believe me, is not going to be easy when all you know is how to find the next word in a sentence. So what could you do? Well, you could give it a preamble that says, hey, before you say the answer, write a lot of drafts of what ideas you have, what you're thinking, anything like that. And so the model starts saying a lot of stuff. Some of this may be right, some of this may be wrong, but everything it says, it can put it in the rearview mirror and revise it. And so once you put this in the rearview mirror, then if the answer is there, it's going to be able to find it because, as you know, models are better critics than creators. So they're not very good at creating that, but they're very good at grading it and analyzing it. So if in all the stuff you said, there were 3 correct things, the critic is going to be able to find them. So you're using the strength of the model, which is the critic, not the actor. And so over here, well, the answer was there. So now the model is going to answer correctly. Now, DeepSeek was the one that developed this very well, and they went even farther. They used reinforcement learning to actually grade the drafts. So they actually used a loss function that would tell you if the draft was good or not using heuristics or using other language models to actually grade it. So they did this very, very well. Imagine that what they did is that when you're training the student to write a good solution, you not only check if they were right or wrong, you actually go to the draft and say, hey, this step was good, this step was bad and it could be improved, etc., etc. So it made it really strong. And that's when machine learning models started being able to solve complicated math problems. If you want to know more about what DeepSeek did, check out this video called Group Relative Policy Optimization that I have on my channel. The link is in the comments. And that talks about this process in detail. Now we finally get to strategy number 4, which is agents. AI agents. And we've already seen them because RAG is one of them. But first, let me tell you, why is it that we need AI agents? Well, I have a big belief, and is that technology maybe doesn't always repeat itself, but it always rhymes. So let's look at the internet. When the internet started, what happened? It was a lot of text. The pages were mostly text, and you would write emails and get text back. It was text in, text out. Then something happened. Images started appearing. Video started appearing, audio started appearing. It became a multimodal thing. And the next step was that it became a tool. You could do things in the internet. Now that's very natural now. But believe me, when the internet started and I was around for that, if you were to tell me that I was going to do a bank transaction on the internet, I would have laughed. And it would have sounded as ridiculous as if you say, hey, you have to put the check in the toaster and then ping, out of the oven, the money comes out. It was that ridiculous. I would have never imagined doing transactions in the internet. Now I can't imagine anything else. All my bank transactions are done in the internet. So the same progression is happening with language models. See, when they started, which is not long ago, it was just text. You would say text and you get text out, text in, text out. Then you started creating images and it started reading images, and audio and video started coming in and out, not as input only, but also as output. And the next step is that it becomes a tool. So now models are going to be tools. And believe me, it sounds crazy to think that we're going to be doing a lot of stuff with AI, but in the future, it's going to be like doing stuff with the internet. And agents are the first step towards doing things with AI. Now, let me tell you a bit more about agents. They have three main things: the brain, the tools, and the memory. But this is better explained with RAG, because RAG is an agent, right? What does RAG do? Well, it has a brain that is the one that operates all the moving pieces. It has tools. Tools are the functions. So the functions are: rewrite the question as a search query, search in Wikipedia, answer the question with what you have. These are basically functions that you write in a program. And finally, it has memory, because when you're going to use this function, you need the memory of the original question and the search results. So that's it. That's an agent. Let me give you another agent. Let's go back to the math problem. I'm going to ask it how much is 3 plus 7. So as we talked about before, a model that knows how to pick the next word in a sentence is not going to know how to subtract and how to add. Maybe it'll figure out from reading the whole internet, but believe me, a square root is not going to happen from picking the next word in a sentence. So it's just going to answer with a number. It knows it has to answer with a number, but it doesn't know what the number is. So what can I do? Well, I could write a preamble that says, hey, if you're getting a numerical question, before answering, open the calculator and plug in the equation that I gave you. So now it's got an API call. So that's another level, but it can do it. And then put the results that the calculator gave you on your rearview mirror. And then with all that information, including the question, the preamble, and the results of the calculator, you can answer the question correctly. So here is something interesting that shows us the behavior of language models. Let's say I have the question: I have 10 apples and I ate 4. How many do I have left? So I could answer with 10 minus 4, as in 10 minus 4 is the equation that comes out of that word problem. Or I could also answer with a 6. Now, for a human, they both seem equally hard. But for a language model, can you tell me which one of these two is really easy and which one of these two is really hard? Well, the first one is really easy because it doesn't require math. It only requires language. You see, if you only know language, you can come up with that equation, because you can look at the word problem and say, hey, it seems like you have 10 and you're removing 4. So it requires a little bit of math thinking, but not very much, because it's basically rewording something. On the other hand, coming up with the 6 is very hard because you need to know the rules of subtraction. And that's another beast. For humans, it's easy, but for a model, that's very hard. So here is how to make the calculator agent using the strengths of the language model and not the weaknesses. You're not going to ask it to give you the answer, but you're going to ask it to reword it in a way that an equation comes out. You're going to tell it to extract the equation from your problem. That's not so hard for a language model. And then once you have that equation, you plug it in the calculator and you get 6. Now, with the 6 and the equation and the question, you put it all in the rearview mirror and you say, now answer my question. Well, now the computer can answer your question with great accuracy. Now, in this agent, where's the brain? The brain is the one that operates all these things. The tools are the functions like get the equation, extract equation from the text, use the calculator API, and put it all together and answer a question. These are perfectly well-defined functions. And the memory is the memory of remembering the number that came out of the calculator, the equation, and the original question. So search and reasoning, which we saw already, kind of behave like agents, right? And they're actually embedded in the language models. For example, when I use DeepSeek, I can actually press the Deep Think button, and that says, before you respond, write a lot of drafts. When I needed to do something logical or something mathematical, I always press the Deep Think button. You can also use the search button that says, before responding, Google search the answer. I use that whenever I need something that is a fact. So if I need to write a poem, I don't use any of the buttons. But if I have a math problem, I use the blue button. And if I have a fact problem, I use the yellow button. And sometimes I use both if I need something more complicated. Now imagine having more buttons. When I need a calculator button, for example, I can just press it. And if I ask a numerical question, I say, hey, before responding, use a calculator. I could also have a lot more buttons like bank or code or other things. So if I have a bank question, I just press the bank button. If I have a coding question, I just press the coding button. Or even better, I could have a router that looks at what I'm asking, finds out if I'm asking a fact or a reasoning question or something with numbers or something with the bank or something with code, and then it routes it to the correct agent. Now, is this hard? Well, it's not so hard because the router is basically asking a multiple choice question. And the first thing we saw in this video is that multiple choice questions are very easy for a language model. So we're using the strengths of the model. So I like to think of agents as a Swiss army where you can open a lot of APIs, give a lot of calls, use different things, and not just talk, but do stuff. Now, here is a problem. Let's say that you want a model to tell a story or to write a book. And I encourage you to try this. Tell any language model to start telling you a story and then keep prompting it continue, continue, continue. This is the modern equivalent of pressing that middle button in the autocomplete app and getting it to spew a lot of nonsense. Because language models are good, but if you make it write a long story and you keep saying continue the story, continue the story, continue the story, you're gonna realize very quickly that it has a lot of weaknesses. The name of the protagonist in the story is gonna change in chapter 3, and the story is gonna change in chapter 4, and all things are gonna go insane because this thing cannot carry a story for that long. Maybe soon it'll have an even bigger context window, but as of right now, a model is not very good for writing a long book. In the same way that the autocomplete Dory was not very good for writing sentences, this one's not good for writing long books. But we can help it with what's called a multi-agent system. So I'm going to come up with one here, but I encourage you to actually think of different architectures because there may be better ones. But I'm going to have a bunch of agents. Each one of them is an LLM equipped with some tools. There's going to be the creative one, the planner, there's going to be the critic, and the writer. So how are we going to tell it to write a book? Well, the first one's going to come up with a short story, something that's short enough that it can be consistent. It's going to say the story is about X, Y, Z. It writes it using the headlight, so it has to be short in order to be consistent. Now, this one passes the story to the planner. Now, the planner has the story in its rearview mirror. That's a strength. And then it comes up with chapters. It says chapter 1 is about this, chapter 2 is about that, chapter 3 is about that. It gives it to the critic together with the short story. Now, the critic has a lot of stuff in its rearview mirror, means it can analyze it really well. The critic is very easy because models are better critics than their actors. So the critic comes up with some feedback. It says, I think I found a discrepancy between chapters 1 and 3. The name of the protagonist is not the same. The city also changed. So please fix that. It gives the information to the planner, puts it in the rearview mirror. Now the planner can come up with better chapters. And you can iterate and do this many times until you have perfect summaries for chapters. Then you give this to the writer, and the writer starts writing chapter by chapter. Now the writer is now fixed to a story that's on his rearview mirror, so it had less chance to mess up, and so it'll come up with something. Now, it's gonna give it again to the critic, and the critic is very good because models are very critics than they are creators, so it's going to come up with some really, really good feedback, and it's gonna bring it back to the writer, and they can iterate a lot. And that is a way that you could potentially come up with a long book using several LLMs, each one acting as agents. Now, each of these agents has tools, memory, and a brain. The brain appears in every agent because the brain is the one that dictates everything. Now, what about the tools? Well, the tools in the creator are plan the story. The tools in the planner are to plan every chapter based on the plans that the creative gives it. The tools of the critic are to give feedback, to check consistency, maybe check the spelling, the grammar, check if it flows, check the narrative. And the tools of the writer are basically to write the chapters based on the stuff it's given. What about the memory? Well, the creative has to have the memory of the story, the planner has to have the story and the chapters in memory, and the critic has to have the story, the chapters, and the previous errors, and the writer has to have the story and the chapters and the errors and more stuff. Notice that there are local memories and global memory. Each of these agents can have some memory for itself, and there's also a general memory that they can all access, like the story that's going on. Now, there's something I want to address. As you can see, each one of the agents has a lot of functions. Now, as I'm building this, when you're building this as a developer, you may run into a question, which is, I have a new function to add. Do I need to give it to an existing agent as an extra function, Or should I create a new agent and give that agent a new function? Well, ideally, you don't want that many agents, but you also don't want to overload an agent with functions. So how do you make this decision? Well, this decision is exactly the same decision you would take if you have humans in your team. Let's say that in my team, we have a doctor that's performing a lot of doctor functions. And I need a new function like perform surgery. Well, I'm going to ask the doctor to maybe include that among her functions. But if the new function is read a lawsuit, I can't ask the doctor. I need a lawyer for that. So I need to hire a lawyer. So the decision you're making with teams, either you hire someone else or you give an existing person a role, is the exact same decision you're going to take when you're building a multi-agent system. So here is a little multi-agent system that I've built. It's called math or fact. So you ask it a question and the first agent checks if the question is math or if it's fact. If it's none of them, then it just says, I don't know. So it's the router agent that tells you if you're fact or if you're math. If the question is a fact, it sends it to the RAG agent, the Wikipedia agent, the one that looks and answers. And if it's a math question, then it sends it to the calculator agent. So it's a 3-agent system. And then based on the answers it gets from whichever of these two, the same router agent has another function called answer the question, and then it answers the question really well. Now notice that this agentic system has a very important property, which is that every time you use an LLM, you emphasize on the strengths and not on the weaknesses. So for example, the router is asking a multiple choice question. That's easy for an LLM. That's the first thing we saw. Multiple choice questions are easy. The Wikipedia agent is answering a question with the stuff that's on the rearview mirror, which is the Wikipedia results. So it's using its strengths. The calculator agent is answering a question with the results from the calculator app. So it's using its strength, which is the rearview mirror. And finally, the agent that answers, which is the same router agent with an extra function, is able to answer the question, putting in the rearview mirror all the stuff that came from the other agents, including the initial question. So all of them are using the rearview mirror and they're not using that headlight very much. So that's the point of agentic systems, to be able to do things utilizing the strengths of LLMs and mitigating their weakness. However, after seeing all this, I still had a question, and I had it for a while. You see, when I first took a programming course, that programming course was about object-oriented programming, where they would tell you, hey, don't write a big program. Instead, have different classes, different objects, and have them do different things and pass information around them. So this object does this, has some functions, pass it to this one operates with it, and then passes it to another, and so on. And you would have a big system with a lot of objects. Now, I'm sorry, but that looks a lot like a multi-agent system. And for a while, all I did when I talked to experts in agentic systems, I said, hey, how is that not object-oriented programming? And I finally understood that there's something more. Because for a while, I just thought, are you just doing object-oriented programming and charging more because you're calling it something fancy like multi-agent systems? No. Turns out there's something more than object-oriented programming, and let me tell you what it is. Let's say that I have the calculator agent again, and it made a mistake because instead of turning the word problem into the equation 10 minus 4 in numbers, it turned it to 10 minus 4 in letters. Now, when you plug that into the calculator API, the calculator API has no idea what to do. So you could do something. You could write all the possible errors in a program and tell it what to do when each error comes out. But maybe you cannot foresee all the possible errors. So you could just use the fact that this is an LLM, that it has some criteria, and then it's able to say, hey, what you gave me was not good. Help me out. Please rewrite it using only numbers. And then it does that, and then the correct answer comes out. So basically, you're not hard coding all the possible errors that can happen and what to do with each error. You're using the fact that the LLM has been trained with all the internet, and while it's not a person, it can still take decisions and say, hey, I think something happened here that you may have to fix this or that way. So in that way, it's more than an object-oriented programming workflow. It can even do things like create a new agent. For example, if it says, hey, this agent is overloaded, maybe I'm going to create one here and add it to the multi-agent system. It can do a lot of stuff, and the more advanced LLMs are, the more advanced these multi-agent systems work. So I like to think of this as a spectrum, okay? And in the spectrum, I have, on that end, I have fully static, and then I move towards dynamic. What's fully static? Well, it's an object-oriented programming workflow where each object has a set of functions and a set of instructions, and they work together as a team, and they can run into errors that I have already predicted and told them what to do about them. But if it runs into a new error, it has no idea what to do and it crashes. On the other end of the spectrum, we have something fully dynamic, which is a team of humans. For a team of humans, I can give them explicit instructions about what to do and how to handle errors. But if an error comes out that is completely new, if for example the room catches fire and that's not among the rules, somebody's gonna bring a bucket of water and try to put down the fire, because this team has a lot of criteria, because they're humans who have a lot of extra knowledge and they are able to modify themselves if they need. They will hire someone else. They would reorganize the functions among them. They can do a lot of stuff because this is purely dynamic. So over there, you have automatization, and over here, you have full autonomy. Now, where are agents? Well, agents are somewhere in between. They have more autonomy than some static object-oriented programming workflow, and maybe not as much as humans right now. But the idea, the goal of agents, is to bring this as close as possible to this direction as we can, so that we can get to almost full autonomy like we do with humans. Now that's all I wanted to tell you about agents, but I have some code, so please check it out. The links are here. You can also scan your phone and get the tiny URL. There's the RAG, the calculator, and the math or fact agents. You can see that the names have the word BAM on them. That's because I built them with my friend Josh Starmer from StatQuest. So definitely check out the labs if you'd like, and you can play with them and add more functionality if you're interested. So that's all we were going to talk. That was a lot of topics we covered. So congratulations for going through all of this video. I'd like to thank my sponsors. These sponsors supported me and helped me do what I love, which is share the knowledge with the world. So thank you very much for sponsoring me. And as usual, if you like the video, please subscribe to the channel, hit like, put a comment. I love reading your comments. If you have questions or if you have suggestions for future videos, many times I get my topics from people who write in the comments and say, hey, can you put a video about this and that? And then I end up putting a video on that. Or share amongst your friends. And if you really want to support me, you can join the channel or support me on Patreon, and then you get some cool perks like early access to videos or Q&As live with me, or you can even get your name on the video. You can also follow me on Twitter, or check out my page, serrano.academy, where I have a lot of courses, a lot of videos, blog posts, codes, you name it. So thank you very much, and see you in the next video.